Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question now from the October 2016 International A-Level Core Mathematics C12 Edexcel paper. This question is about differentiation of the new P2 specification, and it's about applications of differentiation in maximum and minimum problems, optimization problems, you could say. And this is a very common type of question, and they all follow a very similar pattern. I was asked to answer this question by one of my viewers, and they asked me, do we have to know these 3D shape kind of volumes and surface areas? And yes, we do. And normally, if it's something a bit more complicated like a cone or say a sphere or something like that, they will give you the formula for that. But something like this, like a prism type of shape, they would not normally give you the formula for it. So here it tells us, figure 4 shows a solid wooden block. So it's a solid block. The block is a right prism, meaning like this surface and that surface are right angles. It's like if you looked at it from the side, that would be the base, and that's this part going up, the right angle. That's what it means from both sides. That's a right prism. Okay, and it tells us also that with a length h centimeters. So it's a right prism with a length h centimeters. The cross section of the block is a semicircle. So this is a semicircle, this cross section here. This is a semicircle with radius r. Okay, that's what they're telling us there. Now, the total surface area of the block, including the curved surface, the two semicircular ends, and the rectangular base, is 200 centimeters squared. That's the total surface area of this block. We got to show that the volume in centimeters cubed of the block is given by this formula: V equals pi r times 200 minus pi r squared in brackets over 4 plus 2 pi. Now, they asked us to consider two quantities. One of them is the surface area that they told us, and the other one is the volume. So we got to focus on the surface area and the volume of this shape. That's what we got to focus on. Okay, so that's how we're going to deal with this. We're going to deal with the surface area and the volume of this shape. So they told us that the surface area is equal to 200 centimeters squared. That's what we know. All right. Now, very typical. There's always two quantities, always two things that you have to deal with in such questions like this, and you have to kind of link them together into one equation somehow. All right. So let's start off by looking at the volume of this block. Now, the volume of a prism is the cross-sectional area times how deep that goes. It's like a prism has a constant cross-sectional area from the beginning to the end. So this semicircle shape is the same all the way through the shape from here to there. So we know that the volume of a semicircle is pi r squared over 2. So we can say the volume of this shape, the area of a semicircle, is pi r squared over 2. Pi r squared is the area of a circle divided by 2 because it's a semicircle, times how deep this goes times h. So we know that the volume of this is pi r squared h over 2. All right, that's the volume of this. Now we see what we have to show doesn't have any h in it, it just has r's in it and pi's, right? Just r. The only variable here apart from the only variable here is r. There's no h. So how did that happen? Well, we have to think about the surface area. So let's think about what they told us. They told us the surface area is equal to 200 centimeters squared. So let's make an expression now, or let's make an equation for the surface area. So I know that the surface area of this shape is made up of the base, which is now the base, this from here to here. This is r, that's another r, that's 2r. That's the diameter. It's like this length times this width. This is like the area of the base. So you got 2r times h. So 2rh is the base. Then you have these two semicircles added together, which is basically, I'll just write it like this. We know that one of them is pi r squared over 2. There's 2 times. I'll write it like this for now, just for my steps. But we know that's going to become pi r squared. Those two together make a whole circle. That's the surface area of the two ends. Then you have the lateral surface area, means the surface area of the curved part here. Okay, the curved part here, if you were to flatten it out, it would make some sort of a rectangular shape. It would become like a rectangular shape, where this would be the, this basically the half the circumference. So it's 2 pi r over 2. 2 pi r is the whole circumference of a circle. From there to there is 2 pi over 2, and this is h. So we can say that the area of this curved part here is going to be 2 pi r h over 2. So they cancel out, so it's pi r h. So plus pi times r times h. Okay, so that's going to be the surface area. You've got the base, you've got the front and the back, and you've got the curved part. Okay, I'll just write this out like this for now. That cancels out, that cancels with that. So we can say the surface area therefore is 2RH plus pi r squared, okay, plus pi RH. And we know that that's equal to 200. So I can say from here, I can say 2RH plus pi r squared plus pi RH is equal to 200. All right, so I have like, there's an equation here and there's an equation here. I have to combine them together somehow. How do I combine them together? Well, look at what we've been asked to show. Here, there's no h in this equation. All right, what we have to show, there's no h in it. Okay, here there is a h in it. How do I get rid of the h? Well, I take this equation. So it always works like this, actually. You always get two quantities. You can make an equation. One of the things that they give you a value for it. Like here, the surface area, they give us a value. You can make an equation for that. And the other one, they don't give you the value, but that's what you have to express. You have to express the volume as, this expression. You'll always notice that there's something in the one they gave you an actual value for. There's a letter, there's a variable here that is not in the answer that you're supposed to show. So here what's missing is the h. So what we should do is we should make that h the subject of this. So I'm going to make h the subject of this. So therefore I can eliminate it from this equation. So I can see here I'm going to keep the h's on one side. So I've got here pi rh plus 2rh equals, and here I've got 200 minus pi r squared. So I'm just subtract this from both sides. Now I can see h is common on this side. I want to make it the subject, so I'll take it out as a factor. So I have h times pi r plus 2r. Okay. And that's equal to 200 minus pi r squared. So I can say h therefore is equal to 200 minus pi r squared over pi r plus 2r. Okay, I can even simplify that a bit more in case it makes it easy for me later. I can write this as r times pi plus 2. Okay, so that's the value of h. Now, I need to eliminate h from this equation, so I can basically take this and put it instead of this h over here. So I can say that v is equal to pi times r squared over 2 multiplied by 200 minus pi r squared over r times pi plus 2. Okay, we can see that we've got this. Now, what will that give us? Well, I can take this r will cancel with this r. All right, and I'm left with pi times, and this is what we have to show here, pi times r. You got pi r. On the top here we got 200 minus pi r squared. Okay, and underneath what do we have? 2 times pi, which is 4 pi plus 4. 4 pi plus 4. 2 pi plus 4, sorry. 2 pi plus 4. 2 times pi is 2 pi plus 4. And that's exactly what we have to show. Let me just write it in the same way as they require us to. So I can write this as, I can say v is equal to pi r times 200 minus pi r squared divided by 4. I'll write it in the same way, 4 plus 2 pi. It's the same thing. And there we have our answer, exactly how we're supposed to show it. So there's the answer to part A of the question. Now we're going to go on to part B. Okay, now to part B. All right, now part B says, use calculus to find the maximum value of V. Give your answer to the nearest cubic centimeter. So here we have the equation that we have just formed for the volume, which they gave us. Now, one point is, supposing you did not know how to do part A, or you didn't get this, and you tried to do it and you didn't quite get this. Don't say, all right, I couldn't do part A, let's give up. go to part B. It's worth 6 marks. Okay, that's worth more marks than any other part of the question, actually, right? So don't throw away marks by thinking, oh, I can't do part A, so therefore I can't do the whole question. No, you might be able to do part B. All right. All we have to do basically is use differentiation on this. Okay, so that's what, something that's you keep in mind in an exam. Don't just throw away marks. Don't think, oh, I couldn't do part A, so I can't do the rest of the question. Most cases you can, and the way that they set up these questions is, they say show that or show this, and then that means you can use that in other parts of the question and get the marks for those parts. So don't throw those marks away. All right, now we want to find the maximum value of V, and they've given you a clue, use calculus. So the maximum and minimum values are given when you differentiate something. So here we got to differentiate V with respect to R, and you equate it to 0, because that's where you have a maximum or a minimum in curves. You have a maximum and minimum both when dV/dr, when the differential of this function, when you sketch the function, you have a zero gradient. That's where you have the maximum or minimum values. So now we've got to find the maximum value of V. So we got to make dV/dr equals to 0. So first we've got to find what dV/dr is. Now the way it looks here is not very friendly for us to find dV/dr. So what I'm going to do is I'm going to first of all separate these into 2 separate fractions. So I have V equals pi r over 4 plus 2 pi minus pi r squared. So pi r times 200. Let me just first of all expand it. Let me expand it first. So I have 200 pi r minus pi, you can say squared r cubed. All right. So I expanded the numerator, and then I write it as 2 separate fractions. 4 plus 2 pi, and this is 4 plus 2 pi. So I've just basically expanded this bracket. Okay, so 200 times pi r minus pi squared r cubed, and under this, these two, I've split this into 2 separate fractions. All right. Now, what I'm going to do is I'm going to think about this. Here you have basically 200 pi over 4 plus 2 pi. This is actually just a number. Pi is a constant. It's not a variable. Okay, so you can write this as this constant times r. It's just like a number times r, minus, and pi squared over 4 plus 2 pi is also a constant. It's just a number. All right, so it's this times r cubed. This is the variable, this is the constant. It's just like, for example, if you had 2r minus 3r cubed, if you had something like that. Okay, and you can differentiate that very easily, right? So just don't get caught up with this pi and what's this pi and stuff like that. This is just a constant. If you want to, you can even write it as a decimal, but I wouldn't advise that. Keep it as exact form until the last minute. But basically, there's no difference between that, what I wrote here, and this. They're both the same. Okay, so constant times r. So we can find dV/dr. Basically, when you differentiate a variable with, like, for example, if you differentiate 3x with respect to x, it becomes 3. You drop the variable, right? So I'm going to drop the r. This is going to give me 200 pi over 4 plus 2 pi minus 3 times this coefficient. So it's going to be 3 times pi squared over 4 plus 2 pi, and you take a 1 away from the power. Okay, so it's this 3 times this constant times r squared. That's dV/dr. So as we mentioned, we want to find when dV/dr is equal to 0. Okay, so when dV/dr is equal to 0, the maximum, 200 pi over 4 plus 2 pi minus 3 pi squared r squared over 4 plus 2 pi equals 0. If we multiply both sides by 4 plus 2 pi to get rid of this fraction, you're left with 200 pi minus 3 pi squared r squared equals 0. Let's make r squared the subject to find the value of r first when we have the maximum. So 200 pi is equal to 3 pi squared r squared. So we can therefore say that r squared is equal to 200 pi over 3 pi squared. One of the pi's cancels out. So we can say r is equal to 200 over 3 pi under the square root. That's the value of r. Now, they didn't ask us to find r. They asked us to find v. Okay, and we know that this formula here, let me just copy this. This is the formula for V. Now we know the value of R. Now remember this, as I mentioned before, this value, this R is just a number. I could actually work out what it is as a decimal now and use that number in my, use that number in here and get the answers. Fine, I could do that. I could work out what this is and use that decimal in here, or I could put this in this form in here and then in the end round my answer. I think I'm going to use the exact form. So here you're going to say then when R is equal to this, we want to find the volume. This is the value of R where V will be a maximum. So we're going to have pi times the square root of 200 over 3 pi times 200 minus pi times, now if I square this, if I square R, I'm going to get just 200 over 3 pi divided by 4 plus 2 pi. When I put that in my calculator, I'm going to get the value of V, which I then have to round. So what I'm going to do here is I'm going to save this answer. So I'll put the square root of 200 divided by 3 times pi. All right, so I'm going to put that as, I'll store this as A. Okay, so now this is my A in the calculator. So now I'm going to put pi times A. So I'll recall that as A. See, there's the A that we stored in there. Pi times A. And this is 200 minus pi times A squared. Pi times this is what I've stored in here is this, which is R. So I'm going to square that now. Pi times, I'll recall the A. And I'll square that. Okay. Close that bracket. Divided by 4 plus 2 pi. So I've kept everything in its very accurate form over 4 plus 2 pi. And that gives me my answer, which is 187.646. 187.646 cubic centimeters. So we have to round to the nearest centimeter cubed, as it says. Yep, nearest centimeters cubed. So that's going to become 188 centimeters cubed. So there's the answer to part B of this question. Now we're going to move on to part C. It says justify by further differentiation that the value of pi V that you have found is a maximum. Okay, so now we've got to justify that the value of V that we found is a maximum. So to justify further, to find out whether it's a maximum or a minimum, we found that that's where the gradient is 0. But it could be that it was a maximum, it could be that it's a minimum. That value of R that we found could cause V to become a maximum value or a minimum value. We have to show that it is actually a maximum value. Now, by further differentiation means not by using any tabular type of method, but by using differentiation. Now, what we should know is when we find the second differential of a function, we are finding, first of all, the first differentiation. When you differentiate the first time, you're finding the gradient of the function. How the function changes in terms of whether it's getting bigger or smaller, whether it's rising or decreasing, or getting higher or larger or smaller with time. When you are finding the second differential, you're finding how the gradient is changing. So we're finding whether the gradient is increasing or decreasing. So dV/dr tells us whether how V is increasing or decreasing. All right. If I take the second differential, if I differentiate the first differential, okay, that gives me d squared V. Okay. And I differentiate with that with respect to R. That gives me dr squared. D squared V dr squared. That tells us how the gradient is changing. Now, if the gradient is going from positive to negative, when it's going from a positive value to negative value, you have a maximum. That means at the point where it's a maximum, the second differential has to be negative. And if it's going from a negative gradient to a positive gradient, it means it's increasing. Okay? That means the gradient is increasing all the time. That means the second differential has to be positive. So we have to show that this is the case because it's the maximum. So how do we show that? Well, we find the second differential. So we take dV/dr and we differentiate again. we get d squared v over dr squared. Now here this is a constant, so this disappears. This is just a number, if you remember. This is just a constant. Here we have something times r squared minus something times r squared. So when you multiply that, you're going to get minus 6 pi squared over 4 plus 2 pi times r. Okay, that's dv squared dr squared. Okay, so that's the second differential. Okay, that's the second differential here. Okay, so now we know that the value of r for which v is a, the dv dr was 0, was the root of 200 over 3 pi. So the square root of 200 over 3 pi. So we see what happens when we put this inside the original formula for the volume, which is this formula here. Let me bring it down here so we can see it. So if I put this inside, sorry, no, I don't need this in here. Sorry about that. What am I talking about? We've got to put this inside the second differential. Okay, we've got to find out what happens, okay, to the second differential. Is the second differential going to be positive or negative for this value of r? Sorry about that. So d squared v over dr squared is equal to minus 6 pi squared over 4 plus 2 pi times the square root of 200 over 3 pi. So we can see for sure this is going to be negative, but it's always best for us to actually calculate it. So we're going to put here minus. We're going to have 6 times pi squared divided by 4 plus 2 pi. And that's all multiplied by the square root of 200 over 3 pi. Which actually I've saved, but it doesn't matter. Just done it now. I've actually saved this as a. I could have just multiplied that by a. But anyway, there we have our value for d squared v over dr squared, which you can see is going to be negative 26.5, negative 26.5. Now, you can't leave your answer like that. You can't just show that this is negative and leave your answer like that. When you say justify that the value of v you have found is a maximum, then what you have to do is you have to make a little statement. All right, you've done all the work. Don't lose the marks. Say, as the second differential is less than 0, okay, when r equals that value that we got, when r equals 200 over 3 pi. Therefore, okay, we can say v is a maximum at this point. V is a maximum at this point. Because the second differential is negative, v is a maximum. Okay, that statement is essential. Essential for you to write that statement after showing these steps. Okay, if you miss out that statement, you'll definitely lose a mark from this question. Very, very important. Okay, so there we have a question which is a very typical type of question from P2, and it's about this optimization type of problems. As I mentioned, they always give you two different quantities, okay, from which you can form two kind of like equations. One of them will be an actual equation, the other one will be the expression, and that's the expression that you normally have to show, right? You know, like here we have to find an expression showing the volume, but you'll notice there's always in your, when you start writing this expression, there's always a letter that it doesn't exist in what you have to show, but it does exist in the other expression you can find. So you have to make that letter that you want to eliminate the subject of the other equation and replace that letter with what it's equal to, and then you get the expression required. And then the rest is pretty simple, using differentiation, okay, to find the maximum or minimum values by making the differential equal to 0, and then justifying it. That's always quite common as well, by finding the second differential and showing that when you put that value that you found for that maximum or the minimum in it, it gives you, if it's a maximum, it'll give you a negative. If it's a minimum, it'll give you a positive. Okay, so that's a very typical type of question. Other questions from this paper, once I end up answering them, will be in the playlist that should appear in this area over here. Other questions from this topic of differentiation from P2 can be found in the playlist over here. You can subscribe to my channel by clicking on this link. Don't forget to check out the links at the in the description below the video to find other material you might be interested in. Thank you very much, and see you soon.